all, I would like to welcome all the participants of this online webinar, Teaching Engineering Practice using ICT tools. So before start the section, I would like to welcome all the participants. First of all, I would like to thank our management, Mohamed Sathak, College of AJ College of Engineering and Mohamed Sathak Engineering College, who jointly organized this live FDP on teaching engineering practice using ICT tools. I would like to thank our management and the principal officers for giving this opportunity and continuous support for doing these types of webinars and online programs, encouraging faculty and students and improve the communication, the content between each other. So thank you so much for that support, sir. And I would like to thank Dr. Sindhu sir, admin head, for coining this concept using teaching engineering practice using ICT tools for faculty members, since it is a main topic of the first year. And also it is a very simple one. As a mechanical engineer, it is very easy and simple to understand. But due to the COVID pandemic, we are so struggled to take drawing, since it needs more of practice, live practice, how to draw, how to use the pencil. Since these people are not aware about the scales, protractor, and the protractors and set squares, how to use them. So these are all the things they are not aware about that for the students. So by using this, we find this concept to take teaching engineering practice using ICT tools. So on behalf of our management, Department of Mechanical Engineering, faculty, I welcome you all from various institutions in and around Tamil Nadu, not only in Tamil Nadu, other than Tamil Nadu, from IIT, Kanpur, University of Technology, Bhubaneswar, then Andhra, Kerala. All eminent professors welcome for this program. And I think this webinar will help you to an extent how to take and how to use the ICT tools to draw the engineering drawing. So today our chief guest is Dr. B. Janathan. He is a very eminent professor. He has completed his UG in 1992 at Madras University, and he completed his MTech IIT Madras in 2001. He did his PhD 2005 in IIT. He has more than 25 years of experience in academics. He is doing many roles in the past experience like principal, professor, associate professor, like this. Today, on behalf of our management and the participants, I would like to welcome our beloved Professor Dr. B. Janathan for this webinar. Welcome you, sir.
Thank you, sir.
And also, I welcome the most many eminent professors are registered for this seminar. My wholehearted welcome for all the persons who registered for this webinar during this occasion. Thank you so much, sir, and all of you welcome for this webinar.
Shall I start, sir?
Yes, sir. Now, we have participants. This session will be up to 3:30. After the end of the session, you will be allotted with 5 to 10 minutes of questionnaire section, and feedback link will be given at the end of the session. By completing this, you may receive the e-certificate. Now the Google Meet, previously our Google Meet shoot is allotted 250 participants. Now it is restricted to 100 only. So beyond the 100, now it reaches 100. Beyond the 100, you people are advised to join in the YouTube channel. It's already given. You can also chat or you can also give your questions in the chat box also in the YouTube. It is also given in your correspondence. Thank you for your coming, and the session will be handed over to Dr. P. Janathan sir. So kindly mute your mic and video. It helps to others to see. So if you are not able to see the PPT, you please put there are two Janathan. Janathan presentation and Dr. Janathan is there. So when you pin on the Janathan presentation, you will get started. Thank you so much, sir. Thank you. The session is handed over to Dr. P. Janathan sir. Thank you so much.
Good afternoon, everyone. Sorry to interrupt. I am Dr. Balachandra from Sathak University.
Yes, sir.
The chat box is closed. I'm not able to give any chat box.
Yes, sir. Yes, sir. Now it is closed now, sir. At the end of the session, I will open it. Since yes, sir. Purposely it was closed, sir. Since there are so many chat issues, we will not be able to answer it. During the last end of half an hour, I will open the chat box. No problem. Thank you.
Thank you, and sorry to interrupt.
No problem. Thank you.
Okay, good afternoon to all of you. Thank you for the nice introduction about me, Mr. Ramesh, sir. First of all, I would like to thank our management for giving free hand to conduct such programs. So I would like to thank our management, chairman, executive director, administrative officer for giving opportunity to conduct such events. We frequently conduct many webinars like this, and I also like to thank the principal of our Mohamed Sathak AJ College of Engineering, Dr. Srinivasan. I also like to thank the principal of Mohamed Sathak Engineering College for giving this opportunity to conduct jointly by these two colleges. And this idea came when we were discussing with how to take engineering graphics online by our faculty. Initially, we thought we'll have a meeting with our faculty for how to go about this teaching engineering graphics. So when I was discussing with our head administration, Dr. Sindhil Kumar, then he came with the idea that okay, we can have some kind of meeting with our faculty. Then we discussed with our principal. Then he said, why don't we conduct as a faculty development program which can be shared with others also. So that is how this idea came, and whatever little I know about these ICT tools, so I am going to share today. And I also like to thank the conveners of this program, Dr. Mailvel Nathan, head of the mechanical department, Mohamed Sathak Engineering College, and Mr. Ramesh, head of the department mechanical, Mohamed Sathak AJ College of Engineering. These two persons are the conveners for this program. Then I like to thank the coordinators of this program, Dr. Maniganda Kumar of Mohamed Sathak Engineering College and Mr. Saravanan of Mohamed Sathak AJ College of Engineering for having arranged this FDP links and coordinating with other participants. Finally, I would like to thank all the participants, mostly faculty and some students also have joined through the YouTube channel. So I like to thank you for the faith you have with us for joining today to know something about these ICT tools. Ramesh sir, is it clear, sir, my voice?
Yes, sir, it is clear. It's audible, it is clear.
If there is any disturbance, please inform me, sir.
Yes, sir.
Okay. So I have already shared the screen. Now I'll open it. Are you able to see, sir?
Yes, sir.
So this is the FDP on engineering graphics.
I'm not able to hear really well, sir. Could you raise your volume a little bit? I'm sorry.
Okay,
Sir,
okay.
kindly check your...
Sir, your volume also you see the sir level. You can also check
very audible.
because others are saying it is okay. So please
Yes,
check,
sir.
sir. Okay. So this is the engineering graphics using ICT tools. I'm not going to talk about most of the ICT tools, whatever I am using and I plan to use, so I am going to talk about those tools. Many of you are already experienced faculty members. So for some of you, it may be uh, what I call it may not be a very useful or new thing, or for the new faculty who are going to teach, it may be useful, and also for the students. So as the students are also there in the YouTube channel, so I will be talking some things which may be useful to the students also. So kindly bear with me if you are experienced faculty members who have already used these tools. So I would like to start with this quote. As I already told, whatever I have learned is very small. So கற்றது கைமண் அளவு கல்லாதது உலக அளவு. This is the quote from the female poet Avayar. So what it means is, whatever we have learned is a mere handful. When you fold your fingers, whatever inside is what we learned, and what we have not learned is the outside world, that is like a ocean. So that is what the meaning of this கற்றது கைமண் அளவு கல்லாதது உலக அளவு. Then she has also stressed the importance of learning, as never stop learning, ஓதுவது ஒழியேல், then எண்ணல் திகழேல், all these things, never degrade learning, all the meaning. Then Thiruvalluvar has written very harshly about those who are not learned. So கண்ணுடையர் என்பவர் கற்றோர் முகத்திரண்டு புண்ணுடையவர் கல்லாதவர். The meaning is that the learned are said to have eyes, even though unlearned have two eyes that are nearly said to have sores in their face. So that is the importance of the education all these poets have given. So with this, I like to start this. This is the overview of my presentation. I'll talk about our trust, and then about the Mohamed Sathak Engineering College, then Mohamed Sathak AJ College of Engineering. Then I'll give brief introduction about EEG, which may not be very useful to experienced faculty members, but for fresh faculty and students, it may be useful. And also introduction about the ICT tools. I'm not going to talk more about this, but I'll show how to use these tools by using MS Whiteboard and ClassFlow, and also by using the Google Jamboard. Why I prefer to use ClassFlow, so that I'll explain at the end. So this is about the trust. Our Mohamed Sathak Trust is a charitable and educational organization established in 1973, registered under Societies Registration Act by the philanthropic Mohamed Sathak family of Kelakarai, Ramanathapuram district in Tamil Nadu. The founder chairman, late Alhaj S.M. Ahmad Jalaluddin, was the binding force behind the establishment of a trust for the charitable and educational needs of the poor and downtrodden people in the southern district of Ramanathapuram. And also at Chennai, we have various educational institutions. So this is about our educational institutions under our trust. We have in Kelakarai these colleges. Mohamed Sathak Engineering College is at Kelakarai, and Arts and Science College. And we have government aided Polytechnic College, an ITI, an Arabic College. Then in Ramanathapuram district, we have these educational institutions. And at Chennai, we have these many educational institutions. So Mohamed Sathak AJ College of Engineering is situated at Siriseri, close to the Sipcat IT Park. And we have the Arts and Science College, then Architecture College, which is one of the famous colleges in Chennai for architecture. So this is about Mohamed Sathak Engineering College, which was established in the year 1984, and it is one of the very first self-financing engineering colleges established in the state of Tamil Nadu during the year 1984, and we offer UG courses from different disciplines. Some of these are very rare disciplines: aeronautical, chemical, marine engineering also offered, then apart from architecture. Then these are the 7 PG courses offered at the Mohamed Sathak Engineering College at Kilakarai. Then about our Mohamed Sathak AJ College of Engineering, it was established in the year 2001 under the aegis of Mohamed Sathak Trust. The college campus is the area of this campus is around 70 acres, and it is very near to the SIPCOT IT Park. Inside, we can call it as inside the SIPCOT IT Park, Siriseri, where several multinational IT companies are present. We offer undergraduate courses in these 6 disciplines of core engineering, and we also offer postgraduate courses in these 2 engineering in computer science as well as civil structural engineering. Apart from this, we have several the center of excellence. We call it as technology centers for giving training to students other than the curriculum, which is the basic thing. And we have the robotics process automation center. We have the 6-axis pick and place robot for giving training to students. And in the computer science, we have Amazon Web Services Cloud Computing Center. We have so many technology centers, Cisco network. Then for teaching coding to students, we have coding learning center. Then we have the collaboration with Altair for hypermesh teaching hypermesh to students in the computer-aided engineering. We have 3D printing lab with 2 3D printers for teaching these value-added courses. And we have gaming and artificial virtual reality, all these things. And we also have the communication language learning center, where we teach the languages like Japanese language, German language. And these languages are taught by the native speakers. From the Japan, we have one of the trainer for teaching Japanese at our college. So these are the value-added courses we teach at Mohamed Sathak AJ College of Engineering. So now I'll dive into the engineering graphics. So engineering graphics is, as all of you know, it is the universal language of engineers. You need not have the text for this, so it is the universal language. Anybody can read this language. So it is generally taught at the first year in all disciplines. Engineers use this language to communicate technical ideas in a documented form. Many students ignore the importance of the subject, and hence they miserably fail to get even a pass grade. So to tell the importance of this, so these students also have joined today. We have also given the link to students to join. So EG is very important that it helps students to develop new ideas, plan logical layouts, execute designs with a creative approach, and improve their practical skills. So without the knowledge of this engineering drawing, they cannot develop new ideas, because when they are in somewhere shop floor, or if some new idea suddenly comes to their mind, they have to immediately put into the documented form. So this subject is very important for developing new ideas for the engineers. So students face difficulty in understanding this EG. This is because more students they lack in reasonable thinking, then imaginative ability, visualization practices, analytical capacity, logical conclusion. So this is why they are not able to understand this, and they have difficulty in understanding and getting past it. So we have to somehow develop some creative approaches to kindle their mind, so that they will think they will have this imagination power, and they can visualize the solid when we talk about this. So faculty, we have this challenging uh, thing to do to make the students to understand this, because it is one of the new subjects they might not have introduced to this subject at the school level. Even though they have in some boards they have this drawing as a part of mathematics, but they might not have studied exclusively this drawing. This is the objective of the engineering drawing given in the syllabus of the Anna University. We concentrate mainly the syllabus of Anna University, even though many faculty have joined across the country. So mostly it will be same syllabus followed throughout this, except very few changes. So unfortunately, these conventions are not included for the Examination Bureau of Indian Standards, lettering, dimensioning, all these things. So, but we have to tell them the importance of following these standards and lettering, dimensioning. They have to be consistent in doing dimensioning when they complete the drawing. So it is our responsibility to tell the students to follow this, even though it is not included for the examination. So this is the syllabus. As I told, this is taken from the Anna University syllabus. We have 5 units. Unit 1 is plane curves and freehand sketching. So 2D geometry is introduced here, plane curves. And then in Unit 2 also plane geometry here. Projection of points, straight lines, plane surfaces. Then solid geometry is introduced in this 3, projection of solids. So in this, in Anna University, we have only this axis inclined to one of the principal planes by rotating object method. So they are very clearly given. Axis inclined to both the planes not included for the syllabus at Anna University. Then unit 4 is section of solids and development of surfaces. Then unit 5 is isometric and perspective projection. So I may not able to cover the entire syllabus. My idea is to introduce this some of the EG concept. Then we'll go to the practicing of ICT tools for engineering drawing. So even though we have reserved the question and answer session at the end, if some of you have something to ask at the middle, I am open to answer your questions. You can interrupt even in the middle. So, yes, sir.
Sir, question and answer session we will have it in the last, sir.
Yes, sir. Yes, sir. But if they have some specific questions, okay. If they have some specific questions, they can, because faculty only have joined in this. So
yes. Okay, sir. Thank you.
if they feel that it has to be answered now itself, so they can ask. Otherwise, please reserve it at the end. That will be easier.
Yes, sir. Thank you.
Okay, sir. So for proper communication, all the languages will have its own set of rules called as grammar. So engineering graphics also is a language of engineers. So it has its own grammar, and it is put in the various standards we have in India, Bureau of Indian Standards. So these are the code numbers given for this different standardization. Lettering, how to do lettering in the technical drawing is given in this code. Like sizes of the drawing sheet is given in this code. So you can refer to these codes. Various codes are given for the different standardization. So this is like the grammar of any language. So these slides I have prepared for the students to understand. Yes, sir.
That is CD, Naju and Balachandra sir raised their hands.
Okay.
Sir, Balachandra
okay.
Sir.
Sorry again to interrupt. I wish Dr. Janathan to go full screen instead of partial.
It is a full screen.
I have put it in full screen only, sir.
CD Naju, sir. CD Naidu, sir. So Naidu, sir, CD Naidu.
Sir, you might have
Correct.
reduced the size. Please check, sir.
Yeah, it shows 90%. I thought
Yeah,
you
90%. Yes, sir. 90% is my screen is accommodating only 90%, so I have put 90%.
okay, sir. Thank you. Sorry to interrupt.
Okay.
Okay, okay.
CD, sir, Naidu, sir. Okay, sir. Sir,
Okay.
we will discuss end of the session, sir.
Okay, okay, sir. Okay.
Oh, thank you, sir.
So these are the different drawing instruments needed for making drawing. Drawing board is the basic necessity. Then T-square or mini drafter. And we have set squares of 45 degrees, then 30, 60. Then protractor can be 180 or full 360-degree protractor. Then drawing sheet with clips for fixing or sellotape. Then instrument box having the compass and divider. Then pencil, we should have the 3 grades of pencils. So these faculty have to bear with me because you might be aware of all these things, but as some students have joined in YouTube, I have to cater to their needs. So in the engineering drawing, students may have to use these 3 grades of pencils, HB pencil for mainly for sketching, then H grade of pencil for outlines, visible lines, dimensioning, lettering, and for drawing arrows. Then 2H grade you have to use for construction, dimension lines, center lines, then section lines. Then you should have sharpener for making this pencil sharp, then eraser for if you make any mistake, you have to erase, then template for drawing different circles, then for polygons. Then French curve, if it is not a regular circle or part of a circle, then you may have to use French curve for drawing this. These are some of the drawing instruments needed. And why is it called a mini drafter is because the drafter is used in industrial applications. And here we are using in educational institutions only the mini drafter. That is why it is called as miniature version of the bigger professional drafter. So that is why it is called as mini drafter. And some of you might have seen this T-square also. I don't have the picture for the T-square, so it will be like this. It will be in the form of a T. So you might have seen this. The architecture students will use this. So this is again for this like mini drafter. So only if you want to make the parallel and perpendicular lines, you can use this T-square. So in engineering, we'll use only mini drafter. We'll not use this T-square. So some of the students are not able to understand how to use set squares, and they don't even take this set square outside of their instrument box or geometry box. So this is how you can use it for making different angles. So this is the base. This is T square. So this is what the T square I have been talking in the previous slide. So you can use the mini drafter as the reference. Then if you keep the horizontal line is 0, then if you want to make 15-degree angle, so you can use this combination of this 45 degree. This is 45 degree set square, and this is 30-60 set square. So if you use in this combination, you will get this 15-degree angle. And anyhow, you have this 30-60 set square, you have 30-degree angle. Then 45 you have with 45-degree set square. Then 60 you have with this set square. Then again, if you want to make 75-degree angle, then you can use in this combination of these two set squares to make 75. So like this, you can divide this with the multiples of 15 degrees. So I put this slide because many students, they when I ask the students, they are not able to make angles with the set square. So that is the reason I have given this. So you can also tell them, students, to make use of these set squares when they are not able to use mini drafter for some reason, they can even use set squares for making angles. Then we have the how to draw this parallel and perpendicular. So somebody has turned on mic. Please mute your mic. So this is how you can draw the parallel lines. Sometimes the students have to use it is very handy to use this when they do sectioning. When they have to draw parallel lines, they can use set squares instead of mini drafter. So this is how to draw parallel lines, and this is how to draw the perpendicular line. So one line they can draw this AB. So this AB, then if they want to make perpendicular to this AB, they can use another set square like this for drawing these perpendicular lines. So then the students will find it difficult to fix the mini drafter in the drawing board with the proper alignment. Suppose if the drawing sheet is like this in the horizontal direction like this, and if they want to make this, if they fix this at 0 degree, this protractor of the mini drafter at 0 degree, and if they keep the scale like this, it may not exactly coincide with the drawing sheet border. So when they fix it, when they fix first this knob, and if they try to align the scale with the drawing sheet, it may not be perfectly aligned. So what I suggest students to, first they can fix at 0 degrees this protractor, and they can fix this knob. There is a knob here for tightening this scale so that it cannot rotate. So the students who have joined newly, they may not be, they might not have seen the drafter. So this is called the mini drafter with these parallel bars like this, and here also parallel bars. And at the end of this link, you will have this scale with the protractor. So you can fix this knob at 0 degree. Then you can align with the drawing sheet in the drawing board. Then finally you fix this knob so that wherever you take this and bring it back again, so this alignment will not get affected. So if you try to fix this first, then fix this next, then you may have some problem. So this is how to fix the mini drafter in the drawing board with a proper alignment to the drawing sheet. Then introduction about the designation of drawing sheets. So you should know how to calculate the different sizes of the drawing sheets. If you know one size, you can derive from the that size all the other sizes. For example, if you remember this A0 size drawing sheet paper, it will have dimensions of 841 by 1189 in millimeters. The units are in millimeters. The students who have come from the school, they might think only in centimeters. Now this is the time to think from centimeters to millimeters. We will be talking only in millimeters most of the time in the engineering drawing. So you have to think the units in millimeters. So these units are in millimeters. So this is the size of this drawing sheet, which is designated as A0, 841 by 1189. So when you divide this into 2, then you will get the size of A1. So if you divide this into half, then you will get 2 A1 size drawing sheets. So it is very easy now. So dividing. So this size is. So this size is same 841, and now this is divided into half. So if you divide this into 2, it will be 5, 9, then 4.5. So you ignore this decimal, this fraction. So you write only the whole number, so it is 594. So this will be 594. Now if you divide this A1 size into 2 halves, then you will get A2 size drawing sheet. So this A2 size will be, now this is same. So 594 is the size of this. Now this is 841 divided by 2. So 841 divided by 2, if you put, it will be 420.5. Again, I ignore the decimal, so you will get 420 by 594 is the size of A2. Then if you divide this A2 further again into 2 halves, you will get A3, so which you can very easily calculate. So this is the drawing sheet mostly used in Anna University examination. So A3 drawing sheet will be used. So even if you have unstandard size of the sheet, if the teacher asks you to bring the A3 size drawing sheet, then if you know the dimensions, then you can cut from that unstandard size to make it A3 size. Then finally, A4 size paper, what we are using for the printing A4 paper is this size. So when you go to the interview, if somebody asks in the interview what is the size of A4 size paper, because everyday life we are using A4 size paper, so you should be able to tell immediately 210 by 297 mm is the size of A4 size paper. This is for the students to remember this. Then lettering in the engineering graphics, as it is the language of engineers and everyone has to understand what you are writing on the drawing, you should write this lettering in this standard form which is prescribed in the Bureau of Indian Standard. So A should be like this only. You cannot follow your own size of style of writing. You have to follow only these styles for writing this. So you see I should be like this only. Many people used to write I like this and J like this. So in the engineering drawing, which is standardized, you have to use I like this and J. Then M, when we write M, we may write like this, but here M should be like this only. One W, all these things you can see. Then 2 should be in the drawing, 2 should be written like this only, not like this as many people write. And 8, you have to write like this only, 8 should be like this. And 9 cannot be written like this in the drawing standard, 9 should be written like this one. And similarly for the lowercase letter, these are the lettering styles and dimensions also. There are standards, what is the height to the width ratio to be followed, all these you can find from the standards. Then designation of a scale consists of the word scale. We may not able to always draw the full size drawing. When you want to represent a house, okay, you might have seen the plan of a house in a paper, then you may not obviously put the full dimension into the drawing sheet or the paper. So you have to reduce that. That is called as reduction scale. And if you want to draw a miniature kind of things, example IC chips will be of very small size. So you cannot take the original dimension if the IC chips are of only small in millimeter size, 1 or 2 millimeters or even 10 millimeter size. If you draw with the 10 millimeter size the drawing, nobody able to understand this. So you may have to enlarge sometimes. That is called as enlargement scale. And sometimes you may be able to draw with the original scale, that is called as full scale. So the designation how to use scale is, if you write scale 1:1, the meaning is that the original dimension and the dimension in the drawing is same. And if you write a scale 2:1, means you are enlarging by 2 times. If the original dimension is 1, you are enlarging by 2 times. If you write 5:1, then you are enlarging by 5 times. And similarly, reduction scale, if you say 1:2, that means you are reducing the scale by half, by a factor of 2. Then when you say 1:10, that means you are reducing the scale by a factor of 10. You are reducing, if the original dimension is the 100 mm or some 100 meters, and you are representing that in the drawing by 10 meters, something like this. That is the meaning of this reduction scale. So next one is dimensioning. So after making the drawing, one of the important thing in the drawing is you have to dimension. What is the size of that component or the structure? So there are two types of dimensioning called as aligned dimensioning and unidirectional system of dimensioning. In the aligned system, this is how we'll do dimensioning. So this is called the outline of the drawing. So this is the outline of the drawing. This is outline, and these are called dimensioning. So from the object outline, this dimension line will start like this. You have to draw this dimension line. Then you have to do what is this distance. So 20 mm, if you make 20 mm dimensioning, if you are in the aligned system of dimensioning, you have to write above this dimension line like this, so that it can be either read from the bottom of the drawing sheet or from the right side of the drawing sheet. You have to follow like this. So you are not supposed to write this 20 mm below this dimension like this. This is not the correct way of dimensioning. This is not as per the standards. So you should not do this. So again, this 50 should be written above this dimension line. All these dimensions you can see here. And when you come to this side, it should be, when you read from this right side, it should be above this. So 16 should be written above this dimension line. So this is called aligned system of dimensioning. This is called unidirectional system. So here unidirectional means whatever the angle of the dimension line. So always this dimension can be read from the bottom of the drawing sheet. See, this 50 can be read from the bottom of the drawing sheet. Here this 28 can be read from the bottom of the drawing sheet. So as opposed to this aligned system, so where we will put this 28 in this direction. So you can follow any one of the system, but you have to be consistent in following either aligned system or unidirectional system of dimensioning. So the faculty can insist the students to either follow this aligned or unidirectional, but to be consistent in following this. They cannot combine in the same drawing this for one dimensioning this and for other this unidirectional system. So this is about unit 1. What I want to stress this point is, when we teach this plane curves, we many times, I also used to do like this for completing the syllabus. We may not able to tell where these things are applied, all these things. Then the students will not have interest in learning these plane curves if we don't tell what is the application. If we tell the application where these plane curves are used, like space vehicles, aircrafts, machine components in elliptical gears, civil structures, then the students may have some interest in learning these curves. So please give some introduction. You may not able to give all these applications kinds of thing, but give some introduction about this, then start these plane curves, then it may create interest with this in the students. So the conic sections, I need not give full introduction about this, as many faculty are experienced. So when a right circular cone is sliced by a plane in different angles, then we will get these curves. Circle will get circle when the cutting plane is parallel to the base. When you cut this parallel to the base, and if you remove the top portion, and if you see the remaining, the curve obtained is called a circle. When you cut this right circular cone with a plane which is inclined at an angle to the base and also to the axis, then you will get ellipse. you can see the ellipse. Then when you cut the right circular cone with a plane parallel to one of its generators, these two are called generators. This is one of the generator and this is another generator. So when you cut parallel to the generator and if you see the curve, then you will get parabola. Then hyperbola is when you it is when the generator, when the cutting plane is not parallel to the generator or even when it is perpendicular to the base, then we call it as hyperbola. Then we have in this syllabus, we have the eccentricity method of drawing this. So we have only eccentricity method in the syllabus. So I'll introduce this eccentricity method. So this is what I have been telling. Ellipse, you have to tell this used in the construction of arches, bridges, dams, elliptical gears, ends of cylindrical tanks, stuffing boxes, flanges of pipes, monuments. Then they may have interest in learning how to draw the ellipse. Rather than if you directly tell how to construct the ellipse, they will think that what is the use of drawing this ellipse. So then parabola is used to in the suspension bridges, reflectors for parallel beams of light in the headlights, then solar concentrators, then hyperbola is used in cooling towers, hydraulic channels, electronic transmitters and receivers like radar, antenna, etc. So please give some introduction, then start this conic section, then students will have interest. Then as the conic is defined as the locus of a point moving in a plane such that the ratio of its distance from the fixed point, that is called as focus, to the fixed straight line is always constant. The ratio is called eccentricity. So for the students, I'll explain this. When you have these two, one is called a fixed line and other is called a fixed point. So I'll draw this. This is the fixed line. This line is called as directrix, and I'll take some point here. So this is called as focus. So when you move this, when you trace the locus of a point moving in a plane such that this distance from this point to this directrix line is always, the ratio is constant. So when I move like this, for the ellipse, if I move like this, so this is the ellipse. So when you, wherever this point is, when you calculate this distance, so this some P point and then this some E. So this distance, if you calculate PF by PE, so this should always be constant. When this constant is less than 1, we call it as ellipse. So when this ratio is called as eccentricity. So the ratio of the distance of the point from the fixed point to the fixed line, this ratio is called as eccentricity. So here one example problem I have given in the ellipse, but if you see here, nowhere the word ellipse is mentioned in the question. So this is how the question, most of the questions will be like this. So students should understand the question first. They may able to draw the ellipse if it is given draw the ellipse. But here it is given that eccentricity is 3/4. So they have to understand when eccentricity is less than 1, then it is ellipse. So these things students should understand. And here, when the eccentricity is equal to 1 parabola, then eccentricity equal to 1 means the distance from the fixed point to the fixed line is always same. Then it is called as, the curve obtained is called a parabola. Then if eccentricity is greater than 1, something like 5/3, if eccentricity is given, then it is called as hyperbola. So the question is given here not to solve this, but to understand that the curve asked here is trace the path of a point moving in the same plane. That locus of the point moving is ellipse. So that students have to understand first this question to answer this. So this is the ellipse drawn for that diagram. And one more thing is here, the first thing is you have to draw this directrix, then you have to draw this is called as axis. So this line, vertical line, is called as directrix, and this line drawn here is called as axis. So this is axis. Then you have to locate the focus from the directrix, which is given as 30 mm in the problem. So you locate this point. Then you have to divide this distance from this C to F into the number of equal parts. By seeing this eccentricity, you have to divide. So 3 by 4 is the ratio. So if you add 3 plus 4, it is 7. So you have to divide this into 7 number of equal parts. But dividing 30 mm into 7 number of equal parts, you will not get whole number. So there is a procedure for dividing this 30 mm into 7 number of equal parts. So for the students to understand, I will give quickly how to do this. So this 30 mm, if you want to divide into 7 parts, so there is a procedure which is very simple. You draw a line at any angle which can be easily divided into 7 parts. So you can think of 35 mm. So 35 mm can be easily divided into 7 parts because with each pipe, you can easily divide into this 7 parts. So divide this into 7 parts. 1, 2, 3, 4, 5, 6, 7. So now you join this last point with this. Then if you draw this parallel to this, all these parallel to the first line, then if you see, this is divided into 7 equal parts now. Now it is divided into 7 equal parts. 1, 2, 3, 4, 5, 6, 7. So this is how you have to divide. So it is divided into 7 equal parts. Now you have to mark the eccentricity. So eccentricity, how to mark is here the eccentricity is 3 by 4. So the definition of eccentricity is the numerator is the distance of the point from the fixed point. This is the distance of the point from the fixed line. So this is the point, and from here you have to take 3 divisions, and remaining 4 divisions you have to take from the fixed line. So that is how this vertex is marked here. Then there is a procedure for drawing this ellipse, which I am not able to give because I have to introduce the ICT tool. So then you have to divide this into some arbitrary number of, it need not be equidistant. You have to draw these lines. Then you have to cut arcs, all these things. Then one thing a student may not understand is how to mark the other end of the ellipse. So here this vertex is this end, and they will get, after getting this arcs, they will get these points P1, P2, P3, all these things. But they will have difficulty in the other vertex. So this can be easily marked by drawing a 45-degree line from the focus. So this, even many faculty may miss to tell this. If you tell this, then students may able to finish the curve with a perfect ellipse. So from this focus, draw a line at an angle of 45 degree. Then when this line cuts this, the line from this line, that is in this figure they have drawn the downside. And in some books it is explained you have to construct this VF in this direction, okay, equal, and here you have to draw this line. So it can, both are same, whether it is drawn in the bottom or in the upside, it is same. So from here, if you draw this 45-degree line where it intersects this line, then from here if you draw a vertical like this, so that intersection point will be the other vertex. So now students may able to complete the perfect ellipse. So this is the hint you have to give to the students to get the other vertex also. So then parabola is similar to that. Only thing is this is open-ended curve, whereas ellipse is the closed curve. So here, whatever the number of points you take, this is not going to close. It will go like this. Okay, it is not going to close. So this is parabola, and here the eccentricity equal to 1. That means the distance, this distance to this point, this distance is same as this distance. So the ratio is 1. So this is the parabola. Then this is the hyperbola. It is given here. See, this I have taken to tell that whatever you take from the internet, don't assume that it is correct. So here they have given the ellipse problem because eccentricity is 2 by 3. So eccentricity 2 by 3, and they have explained the concept for drawing the ellipse, all those things. But they have drawn here the hyperbola, and they have mentioned here hyperbola, which is not correct. So check the correctness when you copy from the internet. So they have given nice color, all these things, but they forgot, they have taken some other figure and pasted it here instead of ellipse. So this is actually hyperbola because the eccentricity is more than 1. You see here, this is 3 by 2. So 3 by 2 they have taken instead of 2 by 3. So here as this is more than 1, so this represents hyperbola. So please check when you copy from the internet before sharing with the students. So this is about cycloid. Again, I am not able to explain this cycloid. So cycloid is used for small gears in instruments like dial gauges and watches. If you tell these applications, then it will create some interest in students to learn how to draw the cycloid. So cycloid definition is given, and the problem which I have given is, again, there is no word mentioning that draw the cycloid. A circle of 50 mm diameter rolls along a straight line without slipping. Draw the curve traced by a point on the circumference of for one complete revolution of the circle. So students should understand that this is the problem of cycloid. So even without giving the word cycloid. Similarly, this also the problem of cycloid. Then epicycloid is the curve traced by a point on the circumference of a circle rolling on the outside of another circle. So hypocycloid is the curve traced by a point on the circumference of a circle which is rolling inside of another circle. So you have to understand, if the radius of the directing circle is twice the radius of the generating circle, the circle which is rolling on the another circle is called the generating circle. So when this generating circle and this directing circle, the relation is like this, twice, then the hypocycloid will be a straight line. So this, if you give stress the point on this, then students will understand if these kinds of dimensions are given, they will not get a curve. Actually, it is a straight line. So this is the curve cycloid when it is rolling on a straight line. Epicycloid when the circle is rolling on outside of another circle, you will get this. This curve is called as epicycloid. So this is epicycloid and this is hypocycloid. So this is what I have been telling, when the radius of this circle is twice the radius of this generating circle, then instead of getting a curve like this, you will get a straight line like this. So this you have to understand. Then involute, again involute from the definition, you should able to understand the question. Here also, if you see the question, I have taken these questions where there is no word mentioning that draw the involute. A coil is unwound from a drum of 30 mm diameter. Draw the locus of the free end of the coil for unwinding through the angle of 360 degrees. So for the students to answer this question, they have to understand what is the involute. Then only they will know that they have to draw the involute for this question. Many times students know the procedure for drawing the involute or cycloid, or whether it is ellipse, parabola, hyperbola. The only problem with the students is they will not understand the question. They will not give enough time for reading the question. So by seeing the question, they'll start drawing some wrong answer, then they will not get the marks. So please stress the importance of reading the question twice, thrice, or till they understand the question thoroughly. So this is the involute of a circle when it is unwound from the circle. So this is the curve generated, and this is the involute of a pentagon. And I think I'll go to the, I have to skip some of these slides because we have only 25 minutes left for completing this. So I'll quickly go through this. For making the drawings, we'll have three planes. One is called as horizontal plane, which is always horizontal. And there is another plane which is called as vertical plane. And the another plane which is called a side plane or profile plane. So I'll show here. So this is called horizontal plane, which is horizontal, and which is vertical is called as vertical plane. If you assume that there is another plane here, which makes here, so this can be called a side plane or profile plane, where we'll project the onto this plane to obtain the side view. So these are the important views. One is called as top view, and the front view, then side view. So the projection of anything, any object or point on the horizontal plane is always called as top view. Then the projection of the point or any object on the vertical plane is always called as front view. In the civil engineering term, this is called as plan. Some of you might be aware of this elevation and plan. When you see a building, the elevation is good. You might have heard this word. So elevation means front view, plan means it is top view. So this is the top view. If you project anything on the horizontal plane, it is called as top view. If you project anything on the vertical plane, it is called as front view. Then this is at right angles to each other. So we have to document these projections on a plain paper. So we have to rotate this horizontal plane so that we make it in one plane. Now these two projections, front view and top view, are in different planes. So in order to document and keep handy, we have to bring it to one plane. That is what we are doing in the drawing, technical drawing. So we will rotate always this horizontal plane through 90 degrees in the clockwise direction, so that we will bring both the front view and top view in the same plane, so that we can represent it on the paper. So that is what is this projection. It is two-dimensional drawing. Okay. So now we'll bring this whatever there in the 3 dimension, we'll bring it to 2 dimension like this in the plane of the paper. So this is called the front view and this is called top view. So we had brought the projections in different planes. One was in the vertical plane, other was in the horizontal plane. We have brought it into a single plane. So this is called projection, and this is what is called as drawing. So this is called, when we keep the object in the first quadrant, it is called as first angle projection. So this is called as first angle projection. The same thing we can do it by keeping the point in the third quadrant. So when you keep this point in the third quadrant, if you project this on the vertical plane, this is called as front view. When you project this on the horizontal plane, this is called as top view. Again, to bring it on the plane of the paper, we have to rotate this top view, this plane. So this we have to rotate through 90 degrees. So this top view will come in the above XY line, and front view will come below the XY line. So this is the third angle projection. So this is called third angle projection. That is the difference between first angle and third angle projection. I think now we'll quickly move on to the next ICT tools, because the time is very limited. So this can be drawn in any of the tools available. So I'll now show you how to do it in a Microsoft whiteboard. Some of you might have already used. So this idea of using these tools for the faculty development program came when I interacted with some faculty members as I asked them how they are teaching this engineering graphics. Many had used different ideas. Some of the faculty members use paint for teaching. Some use paper and pencil method and they project with the camera. And then some use AutoCAD or Fusion something. So, but whatever available with you and free software tools available, I thought this may be useful. So, I am going to share how to do it with first with the MS whiteboard. So, which is available in the Windows 10. So, many of you might have already used this, or if you have not used, you can use this for using this. So, this is the MS whiteboard. So, here you will have this option. Go to the new whiteboard. So, if you take the scale, you know this, this is available. I can rotate this at any angle. So, now if I take the pen and if I draw a line here, I can draw this XY line. And now when I take this scale, I can mention this as XY line. You can choose different backgrounds if you want for this. So this is XY. Then you can use again this scale for drawing this vertical line. Sorry. I think all of you are able to see my whiteboard. Some quick responses, please.
Yes, sir.
Okay, okay.
Yes, sir. Absolutely.
Okay.
Sir.
Yeah. So now you can bring this to 90 degrees. Then you can, for drawing the construction, you can choose different thickness. So you can choose different color or different thickness. Then you draw this. Then you can mention this. You can take this out. Then you can mention here, which is the front view. Suppose if you have this A dash and here A, then you can draw this. Then again you can use the scale or you can use even freehand for dimensioning this. You can put the dimension like this. Instead of using paint, I thought this will be one of the tools which will be useful for this. So you can mention here, this is how much, if it is 10 mm, if it is 15 mm, you can use this. So this is how you can use this ICT tool, which is Microsoft Whiteboard, which is freely available. And here you can use only the scale and the protractor, which is inbuilt with the scale. But if you want to draw some arcs, circle, except a few shapes available here, you cannot use it effectively for the other the units. So I thought this may not be useful. So I have used the other whiteboard, which is from the ClassFlow. So I'll now show how to use ClassFlow also. And before that, many of you are familiar with Google Classroom, and we can have this Google, there is a whiteboard called as Jamboard. So I'll try to use that Jamboard also. I'll show here how to use Jamboard. So when you click on this, for those who have not used Jamboard, I am just explaining. Others kindly bear with me, those who have this idea of using this Jamboard. So there is a Jamboard here in the Google Classroom, Google itself. So you can use this Jamboard for making simple drawings like this. Again, this is very limited. You cannot use many tools here. You can choose different backgrounds here. You can use this checked, or you can use plain background like this. And here you can choose this pen for drawing this. And here I don't know whether it is available or not. I don't find any scale for making straight lines. So I may have to use freehand for this, drawing these lines like this, which is very difficult to draw with the freehand. Okay, so there are certain limitations in this Jamboard also. And whiteboard is better than this Jamboard because we have this scale and we have the protractor for making straight lines. We can use this. Now I'll switch to this, the other thing. So here, okay, before going into that, I would like to tell this in the straight line for the faculty members who have just started teaching. So the straight line is very simple, even though the straight line inclination is to both the planes, to HP and VP. If you know the inclination to one plane thoroughly, then you can combine that to make the straight line inclined to both the planes. Suppose here it is inclined only to 30 degrees to HP and 45 degrees to VP. Assume that it is inclined only 30 degrees to HP and parallel to VP. So the projection will be, if you draw this, so 30-degree inclination, then as we have assumed parallel to VP, so we will draw like this. So this, if you take this end as A, and this end as B, because this is not the final projection, I will use B1. So here A and this is B1. So this is called the true length and this is called the top view length. And this is the inclination of the line with the HP, which is theta, which is 30 degree. So this is the line inclined to HP and parallel to VP. This is the drawing. Then you assume now it is inclined only to 45 degree to VP and parallel to HP. So now if you assume like this, so this is the corresponding projection. So this is A dash and this is, we call it as B2 dash and this is B2, this is A. So now this is the true length and this is called front view length. And this inclination is called as inclination with the VP. So if you know these two thoroughly, then you can combine these two. Actually, this is combination of these two drawings to make the projection of straight lines inclined to both the planes. So you have to understand whatever may be this inclination, the front view is going to be determined from this and top view is going to be determined from this projection. So here the top view is taken from this. So here this is what first I have drawn. So first I have drawn this thing and here this one. So this is the first projection. I have drawn it separately here. And then I have drawn this second one. I have drawn this one. So what I did is this one. Second one is I have drawn this. And here this is the projection I have drawn. Instead of separately drawing, I have now combined. So this is going to be front view length and this is going to be top view length. So I am just going to rotate this top view length like this to this locus. So which is determined from this point, what is the locus. So then I will get this final top view. Similarly here, front view. This front view length is determined from this. So if I rotate this, I will get this final front view. So before that, you should have located this locus by this point. So this is very simple and these things I'll skip. So what are the ICT tools? The information and communication technology is what is the abbreviation of ICT, which provide access to information through the telecommunications. So what are the tools can be included in this: computers, laptops, desktops, projectors, software programs, printers, scanners, tablets, all these things can be included in these ICT tools. So some of the tools I use here is, I use this Wacom tablet with this stylus. So you can use, I am not representing any company for this canvassing. Okay, since I use this Wacom, I recommend this. Others, if you feel this is better XP pen tablet, you can use any kind of tablet. So I am writing now whatever I am doing it on the screen with this. I am writing in the Wacom tablet only, which is projected on this. So those who cannot afford to buy these tablets, which starts from 3,500 to some it available up to lakhs also. They can also buy this wireless optical pen mouse for this. So they can use this pen mouse for writing this. See, this is not only useful for making this, if you are making use of equations. I think many of you might be aware of this. I'll just give those who are not aware of writing the equations using this. Are you able to see my presentation?
Yes, sir.
Okay. So this pen can be used for inserting equation also. See, there is an option in the Microsoft PowerPoint equation. You can use this equation editor, or you can go for ink equation. Then thing will come like this. Now you can write with this tablet. If I write, it will be instantly converted into the equation. So suppose if I write the bending equation, m by I is equal to sigma by y is equal to E by R. You see, it is instantly converted, and if I say insert, then it will be inserted into this. So it is very handy in doing this while preparing the PowerPoint or while preparing the document. It is very easy if you use this kind of tablet for writing. So that is one advantage of this. Then I am going to show you now quickly in another 10 minutes how to use this ClassFlow software, which comes from a company called Promethean Limited. And this software, why I prefer this software is it is maintenance free software updates, and it is some of the features it is free. Unless you are going for a full featured version, it is they are offering amazingly at free of cost. So then it is 24/7 access to lessons and resources for the students, for learners. They can then no subscription is required, and sign in with your Google account. If you have Google account, you can sign in to the ClassFlow without even having the login. Then simply import your Google roster and resources. You can import the Google the roster. That means students, whoever on roll, you can import to the ClassFlow, and resources also you can import from the Google Classroom. Then make your Google documents interactive by embedding in ClassFlow lesson plan. So you can access from the ClassFlow, the Google, or you can add in the Google Classroom this ClassFlow. Both I'll show you now. So this is from the Promethean company, ClassFlow. And as I told, I am not representing this company, and I am not campaigning or canvassing for this company. And I find it a useful tool which is available at free of cost. So I am just telling to use this. Otherwise, I have no connection with this. Okay. So this is the web-based. It is collaborative software, cloud-based software. It is collaborative, and it is useful for interactive learning with the learners. So I have showed this Jamboard and whiteboard. And apart from this, I think many of you may know what is sweeping tool, which is available in the which I found very useful. You see, earlier I used to whenever I want to take a clip of any screen, I used to have print screen. Then I used to clip that. But a sweeping tool, yesterday only I came to know it is inbuilt in my this Microsoft. So I will show how to use this sweeping tool. Many of you might be aware, but I came to know only yesterday it is very useful. So when you use this sweeping tool, so whatever you want to cut, it is very easy. Yeah, let it open. I'll go to the class flow and open this. So this is what when you type in www.classflow.com, it will open this prod.classflow.com. So you will have both teacher as well as student login. You can log in as a teacher. So you can either log in with your login credentials in the Classflow, or you can use these credentials, Google credentials, to get into this, or Facebook account or Microsoft account to get into this Classflow. As I have login account in Classflow, I log in with the Classflow. This, sir, are you able to see my screen, Classflow screen?
Yes, sir.
Okay.
Yes,
So
sir.
here,
Yes.
yeah.
Yes, sir.
So this is what I like to
Yes, sir.
give. Yeah, I'll show how to add the Google class, they integrate with the Google class, and then I'll show how to use this instant whiteboard. It may take little time. Okay, I may take 10 minutes to introduce. I am also not very familiar with the usage of all the tools. I have also learned very recently this class flow. Okay, yesterday I have practiced many of these things, how to go use all these things. So it is not very difficult when I can learn at the age of 50. Many faculty members who are teaching engineering graphics are very young, so they can very easily learn this, because we are called, those who are at the age of 50, we are called as digital migrants. See, we have migrated from the physical classroom to this digital classroom recently, but the youngsters are digital natives. They are born with these devices, so it is easy for them to learn when compared to others who are digital migrants. So we are all called as migrants, and the young people are called as natives. So classes, I will click on the classes. So there is a new here. So either I can add class here, I can add some class here. So I can put class name as engineering graphics something. Then I can add this class. So there are two categories of class: student generated class and teacher generated class now. So this student generated class is for the college level students, and this teacher generated class is for school level students, because they may not have the account. So we have to create this teacher generated class. Then they can just log in with the code, class code. So I'll just create the teacher generated class now. And if you, some of you can join, it will be very useful, so that you can see now. See, my class code is marked here 69CLR. So some of you may try this. Ramesh sir, if some of our faculty are there, you can ask them to try this. So
Yes, sir.
www.classflow.com/student, if you type in the Google Chrome, see, this Classflow works best with the Google Chrome. So Chrome, if you have, please type, anybody can try this. In the Chrome, you can type www.classflow.com. So here classflow.com/student. You can join class by using this code. So if you join, then I may immediately see who are all in this class.
Yes, sir. Just sir,
So,
what is the number? 16 and
so
B79.
again, yeah, again it is two different classes showing. Like earlier we had a problem, now also it is showing. I don't know. When I
16 and
say here,
CLR.
it is showing different code. I
16 and
don't know.
CLR.
69B79 also try. Some of you can try with this code, and some of you can try with this code, so that it will be.
So 16 and CLR. 16 and
Yes,
CLR.
yes, sir. Is it working?
Wait, sir. sir. It is not the correct word, sir. It is not the work.
Then you try, please try this, sir. Other one, 69D79.
16
Yeah, somebody has joined. Okay, Anbarasu has joined. Okay, thank you. So this is how you can see the students. See, I can see this student. I can remove this student. So, all of you can see. Mr. Anbarasu has joined this. So I have these different things here. So if I start this poll, okay, I have different types of polling here. Creative, they can uh, draw something on the screen and then share with me. So different types of polling are available here. So here it will show when I start this, it will show it is Unverse, you can scribble something on the screen and then you can show it. Yeah, many have joined. Thank you, Vigneshwaran, Vinod, Ramesh have joined this. So I think you will get this. So when I click on show names, it will show names. Otherwise, it will not show the names of this. So this is the class connected with this. So I'll quickly go. Okay, you can easily learn with this all these things. I'll just now open this whiteboard. Okay, so this is the whiteboard. This is what I wanted to show and practice this. So here you can see this pen. So when I click on the pen, you have the option of drawing at any angle or vertical line or horizontal line. So when I want to draw horizontal line, I'll pick this. And when I draw this now, so when I draw this now, whatever wherever you move this mouse, no, it will only draw the horizontal line. You can see very nice horizontal line. So next, when I pick on this vertical line, so when I draw now, it will be only vertical line. So you can see this. So I can very easily draw this XY lines like this. So when you want to draw this any angle, at any angle, now I have chosen, they are giving all these features. So if you buy this software with the smart board, they are giving more features than this. But I think this is more than enough for us to use in the for our educational purpose. Now you can add more sheets. This is like a section. You can add more sheets here. This is one sheet. Then you can also add more sheets by pressing this plus sign, and I have come to the next. Okay, you can still have the previous one with you. So you can refer this previous this slide, and then you can keep on adding all these slides. So this is about the whiteboard. So you have lots of things here. If you want to draw the shapes, hexagon, if you want to draw, you can draw it, and you can increase the size. You can increase the size, and if you want to add text here, you can add some text here, some text, and if you keep it here, if it is not visible, you can make it transparent, all these things. So there are many shapes available, hexagon, pentagon, all the, whatever we need for engineering drawing, circle, we may use only up to hexagon, it is available, even octagon is available, you can use, and square, all these things are available in this. Then you can use this fill screen for making this different backgrounds. Then you can undo this, undo, redo, all the options are available. So I think I have covered all these things. Then select tool is available. You can select and then delete all these things. So you can go to these different slides like this. So then finally, if you exit, it will go to the class flow. I'll say don't save. So I'll exit from this. I think it is taking too much time. It is okay. It has come. So these are this is the whiteboard feature I have shown. This is the quick poll available. So some of you can see when I ask some question, as Vinod, K, CPAT and Anbaras are available, just you can type something. When I ask some question, what is the size of A4 size drawing sheet? When I click on this text, you can text in from your screen and send it to me. When you say submit, it will immediately reach me. So for some reason, it has become very slow, so you may not able to do polling. Yeah, now if you type something, oh, it has come out of, sorry, it has come out from the class flow. Again, I'll try to log in. Sorry for the delay. I'll make it very quick. 5 minutes I can show what are these features available. Then you can play around with these tools on your own. So when I say start quick poll, so now nobody is connected because again you have to, it is saying it is undefined class. So there is some problem. Because many people started using this, sometimes it is becoming very slow. So you have to be, that is coming out of this, I don't know. So I'll go to class and then I'll try to. So I'll show you now quickly how to integrate with the Google class. That is very important. So within 5 minutes, I'll show how to integrate with the Google Classroom, then I'll finish. It has become very slow, sorry. I'll open the Google Classroom. See, I have opened my Google Classroom. Then when you go to the drive, see when you click on this on the drive, when you click new, then you go to the more, then connect more apps, then you can search for the class flow, then you can bring the class flow inside your Google account. So here it is showing many things. So now you type here class flow. Class flow. Then you click on this. Then class flow has come now. So you click on the class flow. Then you say install. Then you it is asking for the class flow needs your permission in order to start installing. You say continue. Then which account you want this, you give the account which you need to be connected. Then class flow has been installed inside my Google account now. So now I can access this class flow from my Google. So if you, even if you close here, now if you see here, you can find out class flow here. So earlier it was not there. Now class flow is inside my Google account. So you can access this class flow from this. So this is how you have to bring the class flow inside Google account. Now I'll show you how to access Google from the class flow account. So somehow it is not opening. It is not logging into my account. So here how to add the Google class into class flow is go to the classes. So here click on the new, then import Google Classroom. If you click on the import Google Classroom, so it will So it has found two classes to import. So if you want to import these classes, you can import from the Google Classroom also. See here, I have just created something second year civil and 11th standard physics like this. So you can, here I have 4 students, here I have 1 student I just added for the sake of showing this demonstration. So here I have 4 students. So if you click on this and then if you say import, if you import this, then yeah, import class. Then with all the four students in the roster, you will get into the class flow account. So you can access this Google Classroom from your class flow also. So all these whatever resources I have in the Google Classroom, I can access from this. So resources, next tab resources, you can see from here you can access Google Drive, OneDrive, Dropbox, all these things. Then marketplace is if someone has created some resources and has put in shared in the class flow, you can directly use those resources for your teaching. So this is what is called as marketplace, and most of the resources are free, and you have paid also, and paid also not very costly. Even with $1, you have many resources in the marketplace. I think it is not opening. There is some error in this network speed. Something my network has speed has slowed down, so it is not opening. So this is what I intended to think. I have done some justification. I don't know whether I have satisfied all the faculty members who are all very experienced than me, and also many faculty members who have used these digital tools extensively. But I have not used very extensively, but I have found this to be very useful in using this tool for teaching engineering graphics. So I think it is time to close this. Okay, this is what I intended to talk. So this is my contact detail. You can email if you have anything. Some questions now. I am open to answer whatever I know. I can share with you. Sir, are you able to hear?
Thank you, sir.
Ramesh,
Yes, sir. Yes, sir. Yes, sir. Thank you, sir. Thank you, sir. Dear participants, if you have any questions to ask the professor, please type in your chat box. It's very easy to capture your question. The chat box is open, so kindly type your question in the chat box. Or if you want to talk to the professor, you can unmute your mic.
You can
unmute your
and
mic and ask your
talk.
question.
Yeah, I'm Dr. Naiju here from Vellore. Thank you, Janardhan sir, for a wonderful presentation.
Thank you, sir.
Yeah, I think you spend more time in describing engineering graphic history. It was mostly like a refresher course for me. And ICT tool was different options. What you mentioned was really helpful for us. And shall I also suggest another one tool which will be beneficial for
yes, sir. Yes,
other
sir.
faculties? Yeah.
Yes, sir.
Actually,
yes,
I had tried this whiteboard and I found another one tool named as Open Board.
Okay.
Yeah, it is more user friendly than whiteboard. So you can also try that.
Okay, sir.
Open,
Do we have these tools, sir? Compass, all these things available in
the everything is there. Say,
okay.
Almost compass, divider, then rulers, protractor, then different our polygon shapes. Everything is available in that.
What is the spelling, sir? Please share, sir.
I'll just put it in the chat. I'll put it in the chat.
Okay. Thanks, sir.
This once again. Open board.
Open board.
Open board. Okay, sir. Thank you.
It's a free tool only, so others can also use it.
Yeah. Okay.
Yeah. Thank you very much, sir.
Thank you,
Thank
sir,
you,
for
sir.
your
Thank you.
sharing this.
Yeah.
Information. Thank you, sir. Anybody else to ask any questions? Sir, can we use Janathan, sir?
Sir, yes,
Can
sir.
we in chat box? Can we use class flow for drawing, for doing straight line topics? SD, Sagar, Aston, sir.
Yes, sir. Straight line. That's what I explained. See, horizontal line, vertical line is very easy, and also inclined line by using the ruler, you can draw this. And for rotating this front view and top view, we can use the compass for drawing the arc. Very easy for straight lines. But for others also, as we have the pentagons, all these things, it is we can use almost for the all the topics in engineering graphics this class flow, and as suggested by other person
IG.
also, we can try with open board also. I don't know what is that. I have used this. I have given this presentation.
Sir, this is
Sir,
sir. This is Sam
yes,
Prasad, assistant professor, sir. Sir,
yes,
Yes,
sir.
sir.
for using whiteboard, sir,
Yes.
compulsory should we get a tab, sir, or can we use with laptop also?
You can use with the laptop with the mouse also, sir. But if you have that tab and the stylus, it will be convenient. Otherwise, for the teaching purpose with mouse, it is enough, sir. So without any further investment, I have devised this FDP like that only. It's not compulsory to use the tab. As I have tab, it is convenient for me to use. Otherwise, with a normal mouse, you can use it. And also
Sir,
that
that
pen mouse you can try because it is very cheap, 1,500 rupees. You can get pen mouse also.
pen mouse, sir. Okay, okay.
Yes, what I have
Uh,
shown in the presentation.
okay,
So
okay.
that is easy. What I have
Uh,
shown in the presentation.
okay,
So
okay.
that is easy for you to write.
Sir, with that laptop should be touch screen or a normal
No, no,
laptop?
not necessary, sir. Touch screen. I have touch screen, but not necessary. You can use all this with your mouse itself.
By using that pen mouse, sir. I'm asking.
Not necessarily pen mouse, sir. Pen mouse, if you have, it is convenient. Otherwise, normal mouse is more than sufficient, sir. See, now we're moving this,
Oh,
and I can use this touchpad in the laptop for rotating this. You can see, I'm not
okay,
using
okay.
screen. I am using only touchpad. Yeah,
Okay.
my touchpad with
Sir,
using touchpad I can use.
okay, this whiteboard is Microsoft or Google, sir?
This is Microsoft whiteboard, sir, and ClassFlow whiteboard also available.
Arun Kumar, sir, there.
Sir, Balachandra sir asked in the chat box, is there any possibility to draw different types of lines, dotted lines, center lines? But we have to take the this mouse on and off, sir. That is the only option, like we do with the pencil. So same thing we can try with the mouse. You press that left click button, then leave it, then again press, it will draw these dotted lines, sir. That way you can do it, dotted line. So when
Okay,
you
sir.
want to draw dotted line,
Anybody
you
else,
have
sir?
to do like this one.
Anybody, professors want to ask any questions?
So I can use scales for drawing this dotted line, sir. Balachandra sir, I think you are hearing. So I can use like this one. I can use center line like this.
Professors, anybody else to ask question? If not, else, we will wind up here, sir. Manikanta Kumar, sir.
Yes, sir.
Sir, what are considering? Janathan, sir, what are considering?
Yes, sir. Thanks all the participants for joining and faith with me and with our team. I think we have done some justification for using the ICT tools for teaching engineering graphics effectively so that it will be useful for the student community. Thank you very much. So now I leave to you, sir.
Yes,
Thank
sir.
you, sir.
Thank you. Manigata Kumar, sir.
Okay,
Okay, sir. Continue the water, sir. Thank you.
okay, sir. Good evening to all. It gives me an immense pleasure to deliver the vote of thanks for this event to all. I would like to thank our Honorable Chairman, sir, Secretary, Madam, Directors of Mohamed Sathak Trust, Chennai. Also, I would like to thank our beloved principals, heads of the Department of Mechanical Engineering, faculty members, and students of Mohamed Sathak AJ in College of Engineering, Chennai, and Mohamed Sathak Engineering College, Kelakarai. Moreover, I especially thank Dr. P. Janathan, Professor, Mechanical Engineering Department of Mohamed Sathak AJ College of Engineering, Chennai, who delivered the excellent presentation about the engineering graphics using ICT tools online teaching. Last but not least, our beloved participants for making this program as a grand success. Once again, I thank one and all present here. Thank you.
Thank you so much, sir. Thank you. So, on behalf of our management, I would like to thank once again all the participants. Thank you so much, sir. Thank you. Thank you so much.
Thank you all, sir.
Thank you, sir. Thank you. Thank you. Manigata Kumar, sir. Thank you.
Thank you, sir. Thank you.
Thank you. Thank you. Thank you.